Welcome to SoCalTech Interviews, where we talk with the startup entrepreneurs, investors, and others in Southern California's technology industry. Today, we talk with Jenny Collins, co-founder and CEO of Novo. I'm Ben Kuo, founder and editor of SoCalTech.com.
Hello, my name is Jenny Collins, and I'm the CEO of Novo. And at Novo, we're developing high-performance electronics for satellites.
And when you say high-performance electronics, what do you mean?
So I think when a lot of people think of space technology, they think of really the most cutting-edge tech is what we put into space. But that's not really true, especially around electronics. So for example, some of the electronics that are built for space today were designed when the 2002 BlackBerry came out. And that's still being launched today. So we're trying to take the pace of commercial technology and put that into space. So instead of taking 2002 technology and satellites using that, we're using modern day electronics.
So for people who aren't familiar with space, especially investors, why is it you can't just take an off-the-shelf commercial, modern electronics and just put it into space?
So the space environment is really harsh, which makes it tough to use commercial electronics. So for example, the first thing you have to survive is the vibrations during launch. Your satellite gets shook really bad when you're on the launch vehicle. Another thing you have to survive is the extreme temperatures of space. When you're in the sunlight, you're really hot, and then when you're out of the sunlight, you're really cold. And when you're hot on Earth, if you think of a computer, you have a little fan that blows on your hardware to take the heat away. But in space, there's no convection, so you can't transfer heat that way because there's no air. So you have to radiate heat away. So not only are the temperatures really hot and really cold, but you have to have an entirely different mechanism to take heat away from your electronics. And then the third thing, and one of the most difficult parts, is the radiation in space. You get charged particles from the sun and other galaxies, and they can either build up over time and cause your electronics to fail, or they can hit once and destroy your electronics. So you have to juggle these three things that are unique to space, which is the vibrations from launch, the extreme temperatures, and radiation, which makes it very tough to design electronics that survive, and that's why we can't use just commercial ones and throw them up there and hope they work.
Interesting. And so what's your background and how did you guys get into this?
So I have an undergraduate degree in aerospace engineering, and then I worked on aerospace and defense consulting in DC for a few years, and then I decided to go back to grad school. I went to MIT, where I did a dual MBA and Masters of Aeroastro. And that's where I met my co-founder, Rodrigo, who is also at MIT studying Aeroastro. And him and one of his old colleagues from his initial job, they had been designing electronics for a decade. And they had worked on some of the biggest, most complex satellites, like the size of a school bus, and some of the really small new ones that are coming up the size of a shoebox. And on their experience working on big and small and commercial and defense, they realized that they were just wasting so much of their time designing the electronics, which is a very complex process. So they thought that there had to be a better way to make it. So that's why they decided to, as one does, design electronics in their free time. Who doesn't want to do that? So it started as a passion project. And then by the time I met Rodrigo at MIT, we talked about it and we helped build it to be a company.
Interesting. And so how far are you from market? And are you using this in space yet, or when will that happen?
So we are already selling boards. They're just development boards. They're not space-worthy yet, but we're working with a couple of organizations to help get our products into space by the end of 2020. And then we'll have the space heritage we need to work on future projects.
Excellent. And the last question is, what's the biggest lesson you've learned as an entrepreneur so far?
I think what's really interesting about being an entrepreneur is, there's a lot of interesting things about it, but I think they say that you really do need to be resilient, and it's true. There's lots of people who will tell you your idea isn't interesting, your idea isn't new, there's lots of folks doing this, why are you working on this? But then every once in a while you meet the person who's like, yes, this is exactly what we needed, we've been waiting for a product like this, and we're so glad that you're here and we can work with you. And you really have to savor and appreciate those moments, because there are people who believe in you and who believe in your tech, and you have to be resilient enough to wait it out so you can work with those people and not the people who don't believe in you.
Excellent.